Stereoisomerism of lactic and tartaric acid. കഴിഞ്ഞ ക്ലാസ്സിൽ പറഞ്ഞ കാര്യങ്ങളാണ് ഇനാൻഷ്യമറും ഡയസ്റ്റീരിയോമറും എന്താണെന്നുള്ളത്. ഒന്നുകൂടെ ജസ്റ്റ് ഒന്ന് റിവൈസ് ചെയ്യാം. ഈ പിക്ചറിൽ കാണുന്ന they are enantiomers. They are mirror images to each other. That's why they are enantiomers. Enantiomers are chiral molecules that are mirror images one another. Okay, they are chiral molecules. They are mirror images to each other. The molecules are not superimposable on one another. That is, this means that molecules cannot be placed on top one molecules and give the same molecules. Chiral molecules with one or more stereo centers can be enantiomers. കഴിഞ്ഞ ക്ലാസ്സിൽ പറഞ്ഞതാണ്, കുറച്ച് എക്സ്പ്ലെയിൻ ചെയ്തതുമാണ്. Diastereomers are stereoisomers that are not mirror images of each other. They are not mirror images to each other, and they have different physical property. They have different. They are non superimposable on one another. There is no concept for that. Stereoisomers which two or more stereo centers can be diastereomers. അപ്പം രണ്ടോ അതിൽ കൂടുതലോ chiral carbon ഉള്ള molecules ആണ് diastereomers ആകാൻ ആകുകയുള്ളൂ. Diastereomers are possible when molecules contain more than one chiral carbon. വളരെ ഇമ്പോർട്ടൻ്റ് ആയിട്ട് ഒന്നിൽ കൂടുതൽ chiral carbon ഉള്ള മോളിക്യൂൾസിൽ ആ ഡയസ്റ്റീരിയോമർ എന്നുള്ള കൺസെപ്റ്റിലും ഡയസ്റ്റീരിയോമേഴ്സ് ഉണ്ടാവുകയുള്ളൂ. ഓക്കെ, വൺ chiral carbon ആണെങ്കിൽ they will be enantiomers. ഓക്കെ, അപ്പോൾ ഈ ഡയസ്റ്റീരിയോമേഴ്സും ഇനാൻഷ്യോമേഴ്സിൻ്റെ എല്ലാം ഒരു എക്സാമ്പിളാണ് നമ്മൾ ഇന്ന് ഡിസ്കസ് ചെയ്യുന്നത്. അഗെയിൻ you see here A and B are enantiomers. They are mirror images to each other. Similarly, C and D are also enantiomers. Actually they are meso, I will discuss later. Or A and B are enantiomers. A and C are diastereomers. A and D are diastereomers. B and C are diastereomers. So this and these two are not mirror images to each other, or this and these are not mirror images to each other, or this and these are not mirror images to each other. So a molecule mirror images to each other allengil diastereomer. They are, if they are stereoisomers and their molecules are not mirror images to each other, they are diastereomers. Diastereomers have different physical property. Enantiomers have same physical property. Okay, don't confuse. We'll discuss again. Don't worry about. Again, you have to try to understand the concept. Optical isomerism of lactic acid. എന്താണ് lactic acid എന്നുള്ളത് നമുക്ക് നോക്കാം. The structure of the lactic acid is CH3 CHOH COH. How many carbon are there? 1 2 3. How many chiral carbon are there? Is it chiral carbon? No, this is not chiral, because C and 3H, 4 different carbon. If a group is attached to 4 different group or atom are attached, they are called a chiral carbon. So CH3 is not a chiral carbon. Now CH3 HOH COH. So this is a chiral carbon. What about this one? This is not a chiral carbon. C double bond OH. So it's not a chiral carbon. Okay. So how many chiral carbon are there for the lactic acid? So it is 1 chiral carbon. So how many optical isomers will be possible? 2 raised to 1, that is 2. Number of possible optical isomers 2. Okay, so this is the lactic acid. Lactic acid അഥവാ lactic acid ഒരു chiral carbon ആണുള്ളത്. So there will be 2 isomers. One isomer, means they are enantiomers, D lactic acid and L lactic acid. D lactic acid means they rotate the plane polarized right direction. L lactic acid means they rotate the plane polarized left direction. So this is another representation. Don't worry, this is COH OH. So they are, one is plus lactic acid, another is minus lactic acid. Okay, so one is dextrorotatory, another is levorotatory. So this is also another type of representation. So CH3, COH, CH. So don't worry about these things. This represented. This is another representation or projection formula. You can discuss later. So it's not important for us. So you see OH, COH, HCH3, CH3. So this is D-lactic acid, L-lactic acid. So they are enantiomers. They are mirror images to each other. So simply two stereoisomers are possible for lactic acid which are related to each other and are non-superimposable mirror images to each other. Lactic acid which rotate plane polarized right directions are called dextrorotatory lactic acid, D-lactic acid. Lactic acid which rotate plane polarized left directions are called levorotatory lactic acid or L-lactic acid. They are enantiomers. They are enantiomers. So enantiomers of lactic acid have identical physical property except for direction of optical rotation. That is enantiomer concept. Both D and L lactic acid have same melting point. Physical property same on enantiomers. 26 degrees centigrade adinte melting point. Above 26 it is liquid. Specific rotation of D-lactic acid is plus 2.24. Specific rotation of L-lactic acid is minus 2.24. Okay, so they have equal, enantiomers will have equal and but opposite optical rotations. Equimolar mixture of lactic acid are optically inactive and they are called racemic lactic acid. Okay, so random equal concentration of L and D lactic acid you have taken, then it is called racemic lactic acid or DL lactic acid, equal amount. Next is optical isomerism of tartaric acid. Okay, let us see what is the tartaric acid. Tartaric acid has the formula.